Alright, this is a quick recap on our Pythagorean Theorem. This is the notes from this Monday. We're going to work through reading this, and then we're going to take a look at two quick examples that will be all you need to practice using the Pythagorean Theorem. First off, our theorem says if A, B, and C are the two legs and hypotenuse of a right-angled triangle, then the lengths of the sides follow the formula a squared plus b squared equals c squared. It is important to recognize the particular sides of the triangle. Our hypotenuse is always the longest side on a right triangle, and is always going to be associated with the letter C. So C, the longest side here, is the hypotenuse. A and B are considered the legs of the triangle. A way to help you remember that they're the legs of the triangle are that they make the letter L. A and B are legs, they make the letter L. If the two sides you're looking at don't make the L, though one of them is not the leg. If you can make an L, both of those sides are the leg. Now, when you're asked to use the Pythagorean theorem, there's generally two types of questions that you're going to be concerned with, or two questions you're going to have to consider when dealing with the Pythagorean theorem. You're going to be asked a question that is essentially, what is the length of the missing side? And you're going to have to identify the sides that you currently have to find and set up your equation correctly. So, looking at this first example, I see 3 and 4 as two of the sides of my triangle here. I don't know what this long side is, but I see it's the long side. I see that the 3 and the 4 make the letter L. So I know 3 and 4 are the legs, and I can label them as A and B. This other side that isn't making the L, the diagonal side in this case, we're going to call it C, and as a reminder, it is the hypotenuse. Hypotenuse. So, since we see the values of 3 and 4 for A and B, we can plug them into our formula. We'll have a squared plus b squared equals c squared. So we'll have 3 squared plus 4 squared equals c squared. We'll square 3 and square 4 to get 9 and 16. We'll add to get 25. And the last thing you need to remember is to square root. We don't want c squared. It looks like c is by itself, and c is by itself, but we need to have c and not c squared. So we'll square root the 25 to get c. The square root of 25 is a nice integer number for us. It is 5. So the length of the missing side, the hypotenuse in this example, would be a length of 5. This set of 3 numbers we have here does get a special name. This set of 3 numbers, 3, 4, 5, is called a Pythagorean triple. If I know 3, 4, and 5 make a right triangle, I know any multiples of 3, 4, and 5 will make a right triangle as well. So because I know 3, 4, 5 works, I know that 6, 8, 10 would work, and I would know that 9, 12, and 15 would work. Because 6, 8, and 10 are just 3, 4, and 5 multiplied by 2. And 9, 12, and 15 are just 3, 4, and 5, each multiplied by 3. These are also right triangles as well. So, in this problem, we found the hypotenuse. We identified that we were missing the hypotenuse, and we had to go ahead and find it. Our last example here, I've oriented it slightly weirdly because not all the triangles are the same orientation all the time. We're going to make sure we identify what our two sides are. Currently I see 5 and 13, and I'm going to look for the L to identify my legs. Again, I can see an L shape right here. You can always also look for the little square that's indicating that we have a right angle there. Those two sides should be the legs. So, 5 is one of the legs. This missing side is one of the legs, and 13 would be our hypotenuse. So this will be our hypotenuse. Let's label it. And let's say C equals, because C is always the hypotenuse. 5 could be the base. 5 could be A or B. 5 could be A or B. And for our problem solving, it doesn't matter which. So I will say A equals 5, meaning we're going to find out what B equals. We'll set up the same problem. We'll go A squared plus B squared equals C squared using our formula. We'll plug in what we know. We know 5 squared plus B squared equals 13 squared. We evaluate in our calculator, getting 25 plus B squared equals 169. We would subtract 25 from both sides. Make that a nicer 25. There we are. To get B squared by itself equals 144. Remember, we will have to square root. So we'll get B equals the square root of 144, or 12. So B equals 12. And that's going to be another Pythagorean triple. 5, 12, 13 would be another Pythagorean triple. So if I can think of any multiples of 5, 12, and 13, if I multiply those three numbers all by the same number, I'll come up with another one. So another example could be I see 60 and 144. If I look and say, oh, 5 times 12 makes 60, and 12 times 12 makes 144, I know the next one has to be 13 times 12, or 156. One important reminder, just to help you check your answer in solving these problems, is that the hypotenuse is always the largest number. It's always the largest side of any right triangle. The hypotenuse is always the largest side of a right triangle. All right, have a good day.